Welcome. Today we are going to solve a JEE Main question on capacitance. This is from 2016 and this is question number 12 if you are following code E. The question is, a combination of capacitors is set up as shown in the figure. The magnitude of the electric field due to a point charge Q having a charge equal to the sum of the charges on the 4 microfarad and 9 microfarad capacitors at a point 30 meter from it would equal, and then the 4 options. So let's see what the question is saying first. What the question is saying that we have to find the charge on these two capacitors. So this capacitor and this capacitor, and then we have to consider a point charge Q, right? A point charge Q which is at a distance of 30 meters from these two capacitors, right? So it's at a distance of say 30 meters, and then we have to find out the electric field due to this point charge Q, right? So that's what the question is. Now let me tell you a little bit about capacitance. Capacitance is given by C is equal to Q over V, where Q is the charge stored in the capacitor and V is the voltage. What is a capacitor? A capacitor is just two plates, right? And they have a distance between them, usually filled with a dielectric material. The dielectric material does not conduct electricity, but it will let the electric field lines to pass through it, right? So that's what a dielectric material is. That's what a capacitor is, and theoretically it's just two plates. In practical you might have seen cylindrical capacitors. They are also two plates, but they are just rolled over each other with a dielectric material between them, so that's why they are cylindrical. And what is the unit of capacitance? Capacitance is coulomb per volt, which is also called a farad after Michael Faraday. And how is 1 farad defined? It's the capacitance of a capacitor in which a charge of 1 coulomb, right? So if there's a capacitor, and if this is plus 1 coulomb and this is minus 1 coulomb, then if this will bring about a potential difference of 1 volt, then it's said to be 1 farad, right? Or vice versa. So this is what 1 farad is. Now let's focus at the question. The question says there's a 8-volt battery here, right? It's DC current, and then there's 2 microfarad capacitor, and then these capacitors. So we know that this and these are in parallel, so the potential difference here will be 8 volt, and here also it will be 8 volt, right? So potential difference will not change. Now we have to find out the charge on these two capacitors, 3 and 9. So we can ignore this capacitor, it's not relevant to our question. Now when the capacitors are in series, they hold an equal amount of charge, okay? So this capacitor and an equivalent of these two capacitors will hold an equal amount of charge Q, okay? This is the basic principle. So what happens is that when potential difference is applied, this plate will develop a potential, okay? So in conventional electric current, the current flows from positive to negative, but it's actually the electrons flowing. So we're going to assume that this plus side electrons are flowing to this plate, right? And then this plate will hold some electrons, right? And then this plate will get polarized and opposite positive charge will develop, and the electrons will be pushed over. The electrons will flow to these two capacitors, right? And then this will have the negative charge, and then this plate will have a positive charge, and it will push the electrons, and the electrons will flow from these two capacitors, and this is how the current will flow in this circuit. So let's find out what the capacitance would be. Now capacitance formula is, if it's in parallel you can just add it up, right? So 9 plus 3 will be 12. So the equivalent capacitance of these two capacitors is 12 microfarad, and then what would be the equivalent capacitance of 4 microfarad and these two 12? You can use this formula. It's just like resistance but opposite. For in resistance, in series you just add it up, but in capacitance you have to use this formula. So it's 1 over C equivalent is equal to 1 over 4 plus 1 over 12, and then if you solve it you will get 3 microfarad, right? You can solve it yourself and see. So the equivalent capacitance of all these three will be 3 microfarad. Now I can say that if this is the equivalent capacitor, it's 3 microfarad. Now we're gonna use this value to find out what is the charge held by the equivalent capacitor, and then we're gonna break it down again backwards to find out how much charge individual capacitors are gonna hold. So let's see how we can use this 3 microfarad. Alright, so we're gonna use this formula right here. C is equal to Q over V, since we know the values. C we just found out is 3 into, I'm gonna write 10 to the power minus 6. It's not necessary, but it makes things clear. So let's make it 3 into 10 to the power minus 6. Micro is 10 to the power minus 6. So 3 into 10 to the power minus 6 farads is equal to Q, which is what we want to find out, charge, over 8 voltage. Volt is given. So Q is equal to 24. I'm gonna multiply both sides by 8, right? So 24 into 10 to the power minus 6 coulombs is what the charge is on the equivalent capacitor. Now we're gonna have to work backwards, and I'm gonna break it down to 2 capacitors. Okay, so I'm gonna make it this capacitor 4 microfarad. Okay, this is the 4 microfarad capacitor, and then I have the equivalent of 2 parallel capacitors, which I know is 12 microfarad, right? So in series I told you the charge on the capacitors is the same, so it's gonna be different in parallel, but in series it is same. So both these capacitors will hold the same charge, 24 into 10 to the power minus 6 coulombs. If you want to understand the principle I explained in the beginning, if you apply it, you will understand. So this will have now 24 into 10 to the power minus 6 coulombs, right? But what is this 12 microfarad? These are actually 2 parallel capacitors, and I have taken the equivalent of these two to get 12. So I'm gonna break it back to 3 microfarad and 9 microfarad. Alright, so now how much charge will be held by this capacitor and how much will be held by this capacitor? In this question I don't need to break it into these 2 capacitors, because they want to find out this Q, and this Q will have the charge of both these 2 capacitors, right? So I don't need to break it in this question, but I'm gonna show you how it's done, just so that you may know for some other similar question that may be asked in the future. So I'm gonna show you how it's broken down. Alright, so this will have 3 and 9, right? So the total charge is 24 microfarads, I'm sorry, 24 into 10 to the power minus 6 coulombs, right? That's the total charge. Now how do I break it into these two? You can take the ratio 3:9. Alright, so if I were to divide 24 in the ratio 3:9, 3 parts would go to the 3 microfarad capacitor and 9 parts would go to the 9 microfarad capacitor. And the way I take ratio is I'm gonna sum up 9 plus 3 and I'll get 12, so I can divide it into 12 parts, right? So 24 microcoulomb divided by 12 is 2, right? And then I'm going to allot these 2 to the 3 microfarad, and the way I will do it is by multiplying 3 into 2, right? So I've done it here. So 3 microfarad gets 3 into 2, which is 6 into 10 to the power minus 6 coulombs, and the 9 microfarad will get 9 into 2, which is 18 into 10 to the power minus 6 coulombs, right? So one part is 2 coulombs, so 3 parts would be 6, and 9 parts would be 18. I hope that is clear. So now I know how to break it up, but I never really had to, because I'm going to add it up again. 18 plus 6 is 24, which is the total charge held by these two capacitors, right? So now I know that this point charge Q holds a charge of 24 into 10 to the power minus 6 coulombs. I hope that is clear. If there is any confusion, let me know and I'll clear it in another video, right? So this is 24 into 10 to the power minus 6 coulombs, and then I can simply use the formula for electric field, which is E is equal to K times Q over R square, where K is the electric constant, which is 9 into 10 to the power 9, and I'm gonna write the units Newton meter square per coulomb square multiplied by charge, which is Q, which is we got 24 into 10 to the power minus 6 coulombs over R square, and which is 30 meters. So I'm gonna square it to get 900 meters. I'm gonna cancel things out here. 9 1, so, and then 9 into 100 is 900, right? And then this is 10 to the power minus 6. So if I remove this 100, it's going to become 10 to the power minus 8, and then 10 to the power 9 and 10 to the power minus 8 will give you just 10, right? And 24 into 10 is 240, and then the units will also cancel out. This is meter squared, right? Meter squared cancel out. 1 coulomb and this will cancel out, so you'll get newtons per coulomb, right? So even the units match, which is kind of reassuring that you are on the right track. So that's the option number 1, 240 newtons per coulomb. Now I know that I've been told that some people have found the answer to be something else, 420 or 480 newtons per coulomb, but you can see for yourself that it's 240 newtons per coulomb. Thank you for watching this video.